Welcome to our FAULHABER Drive Time. In the first few videos of the sequence, I already explained how to use the analog inputs to control the movement, and we had a first example to use analog input 1 to control the speed. In this video, I want to add analog input 2 to control the position of the drive. Once again, I'm going to give a few examples of scaling in a first single slide, and then I'll switch to the live view of the Motion Manager to do this. In my demo unit, the potentiometer, which I want to use as the position reference, is connected to the 5-volt sensor supply at the I/O connector of the motion controller. So the raw inputs I can expect are in the range from 0 to 5000. The scaling of the position is in increments and is related to the sensor system that we are using. And here, using these linear Hall signals, the scaling is 4096 increments per turn of the motor. Now consider moving in a range of roughly 2.5 turns of the motor, so 0 to 10,000 increments. Out of the raw input, this would be an offset of 0. And we would have to have a gain here of 2, and then we can come from the 0 to 5000 to the 10,000 here. When we want to control the position in both directions, so plus minus 10,000 increments, then we would have to have a 0 value at the 50% range of the original input, so at 2500, and that's an offset of minus 2500. And then, of course, we have a bigger output range, and so the gain is a 4 in that case. In case of the full range of the input signal, so plus minus 10 volt, like when you are connected to a PLC, you can either use the limits to limit the movement to the range of the 0 to 5000, or we rescale the scaling here of the analog input. Same when we want to have the motor moving in both directions, so plus minus 5000 increments. In that case, no offset required, because that's the same behavior that the raw signal is having. But here the gain, of course, is 50% to generate a numeric range of plus minus 5000 out of the raw input signal. So here's the view from the Motion Manager. Scaling and selecting of the analog input is done using the Drive Functions window. And the settings for this analog input is in the signal management section of the Drive Functions window. Analog input 1 here has already been scaled as a speed reference. So now let's use the second analog input. It's connected to the same plus 5-volt supply, so the raw range is 0 to 5000, and I want to generate a movement of plus minus 10,000 increments out of this, and using these linear Hall signals, a single turn is 4096 increments, so that's these 2.5 turns roughly when I want to have these plus minus 10,000 increments. So to have movement in both directions, I first of all have to have an offset, and this would be at 50% of the raw range, so an offset of minus 2500, which then shifts the raw range centric around the 0. So now I got a raw input of plus minus 2500. To generate these 2.5 turns, I would then divide by the amplitude of the raw range and multiply by what I want to see as a movement, the 10,000 increments. If I want to have exactly 2 turns, it would be 8192. So the 2 turns, where a single turn is the 4096. Then send the parameters and select this second analog input to be used as the target position source. Once again, I'm going to send the parameter here and select the operating mode. In that case, it would be analog position control. And then I can close the Drive Functions window, enable the driver, and and then the disc is following the movement of my potentiometer here. That's all I wanted to show of how to use these two analog inputs for either speed control or position control references. In the next video, I'll add a small bonus and show you the script that I'm using here to switch between either speed control or position control and to enable or disable the controller here. Meanwhile, if you got any questions, ask your local FAULHABER sales contact or our MC support team. And of course, check back with our channel and please leave a comment here. Bye.